Bismillahir Rahmanir Rahim. My dear students, today our topic is macromolecules. Now, first of all, we have to understand what is meant by the term macromolecule. Macro means large, big, giant, and molecules which consist of number of atoms. So, macromolecules means which consist of such a thing which consists of large number of atoms. They are covalently bonded together. So when you say they are covalently bonded together, it means the bonding between them is very strong. So they have high melting and boiling point. So we have many properties of macromolecules. Now in our syllabus, the macromolecules which are present is most common is diamond, graphite, silicon carbide, and silicon dioxide. So these are the most common, and out of these four, the two are very common and special, the diamond and graphite. Now the diamond and graphite both are allotropes of each other. So what is meant by allotropy? Allotrope or allotropy mean the forms of the same element having same chemical properties but different physical properties. Now you want to understand what is meant by physical and chemical properties. It means that, for example, if you have diamond, if you have look on the diamond and if you have look on the graphite, the both are seems to be different. Diamond is very shiny, it's translucent. On the other hand, you have a graphite. The graphite is present in the lead pencil, in the tip of lead pencil. You can see now it's dull, black. It's not shiny as compared to the diamond. So when you put these two things together, the diamond on one side, diamond other side on the graphite, they are different from each other. They are different. So physically they are different, but chemically they both are same. So chemically they are made up of carbon. So such forms which are chemically same but physically different, they are said to be allotropic form, and this phenomena is called allotropy. Now we have some properties of the macromolecules. So have a look on these properties. Macromolecules are large molecules built up from many small repeating units joined together by covalent bonding. For example, sand, diamond, graphite, these are the common examples of the macromolecule. But as I said, the diamond and graphite, they both are allotropes. Allotropes are the forms of the same element having same chemical properties but different physical properties. Now they have electrons shared, have high melting and boiling points. For example, diamond, graphite, silicon carbide, silicon dioxide, etc. Are soluble in water, insoluble in water, do not conduct electricity except graphite. So graphite is a conductor of electricity. Why? Because it has delocalized electrons. Now have a look on the differences, some of the properties between the diamond and graphite. First of all, have a look on the diagrams. The structure of both diamond and graphite, they are entirely different. You can see on the left hand side the diamond structure, the one carbon atom is covalently bonded with the 4 carbon atoms, while on the right side the graphite structure of the graphite, in graphite one carbon atom is covalently bonded with 3 carbon atoms. So the electrons of the one carbon atom is free, and that free electron is responsible for conduction in graphite. Now diamond has a giant covalent structure. It continues on and on in 3 dimensions, while on the other side graphite has a layered structure. So if there is one layer, then between one layer and second layer there are weak van der Waals forces are present. So this is the difference in terms of the structure. The diamond is tetrahedra, 3-dimensional structure, while graphite is a layered structure. Carbon has an electronic arrangement of 2 4. Each carbon shares 4 electrons with the 4 other carbon atoms, forming 4 single covalent bonds, while here each carbon atom uses 3 of its electrons to form simple bonds to its 3 close neighbors. That leaves a 4th electron free. We call it delocalized. These are there are no longer associate directly with any particular atom or the pair of electron, but are free to wander throughout the whole layer. So as we said, so these are the properties. Then we can further explain that diamond is a hard structure, is a non-conductor. Why it is hard? Because it consists of large number of atoms covalently bonded together. Now it is why it is due to its hardness, it can be used, diamond can be used in cutter, as a cutter. Then another use of diamond in jewelry, because it is translucent, it's shiny. So due to its shiny appearance, diamond is used in jewelry. While on the other side, graphite is opaque, it's not shiny, but because it has delocalized electrons, so so it can be used as a conductor. So it can conduct electricity, and it is a good conductor of electricity because it has delocalized electrons. Now because it has layered structure also, graphite has layered structure, so between the layers weak forces of attractions are present, and these layers can slide past over each other. So due to this reason, we can also say that graphite can be used as a lubricant. While diamond is non-conductor of electricity because it does not have any delocalized electrons. So these are the some of the properties of the diamond and graphite. The next topic is metallic bonding. My dear students, remember, metallic bonding it is present only in metals. This is the first impression about the metallic bonding. What is metallic bonding? It is the bonding which is present in metals. Now question, how the metallic bonding is formed? As an introduction, I want to say, in metals, the valence electrons, they are loosely held with the nucleus. In atoms, the electrons, they are negatively charged, and the nucleus, the protons, they are positively charged, and due to this positive and negative force, electrostatic force, the electrons are revolving around the nucleus. So this electrostatic force is very, very important to keep electrons on a circular path. Now in metals, there is a one thing unique, that the valence electron, when I am saying valence electron, the outermost shell electrons, they are loosely held with the nucleus. So when they are loosely held with the nucleus, so as a result, what happened? They are not you can say under the influence of the nucleus, and they can move around, and when they move around, they surround the positive nucleus like a sea of electrons, just like sea. So you can see this diagram also, that the positive nuclei are surrounded by the negative electrons. Now when this will happen, so there will be another attraction, another bonding between the negative, the surrounding electron, and the positive nuclei, and there will be a force, there will be a bonding, and we call this bonding as a metallic bonding. Because this is present only in metals, so that's why we can say this is the property of the metals. Now you can see this type of the bonding is found only in metals. As I said earlier, metals are electropositive. Electropositive means that metals can lose electron. When they lose electron, they become positive. In nature, that is, they have tendency to lose their valence electrons to form positive ions. The outermost valence electrons become delocalized. This results in a closely packed regular arrangement of the positive metal ions surrounded by the sea of mobile valence electrons that bind the ions together. Now, due to the presence of this sea of electron or delocalized electrons, metals can conduct electricity. There is a question which is very common question, okay, how metals are good conductors of electricity. The answer is because the metals have sea of electrons or delocalized electrons. So, due to presence of sea of electrons or delocalized electrons, metals can conduct electricity. Secondly, because this is a bonding, and this bonding is present in the metals, and there is a one metal except mercury, all the metals are in solid state. So, we can also say that because the metallic bonding is present in the metals, and mostly metals are except one metal, or metals are solid. Already in solid the strong forces of attractions are present, but in metals there are more strong forces are present because metallic bonding is present, and due to this metallic bonding metals have high melting and boiling point. Then we can also say metals are good malleable. Malleable means that they can change their shape, that if you hammer them, if you apply the force, so there is a change of shape. So, this is also property of the metal. So, we call this property as a malleability. Then there is another property, ductile. Metals are ductile. So, ductile mean that we can change metals into different shapes. Into different shapes mean wires, especially wires. So, you know that electrical wiring wires, they are made up of metal. So, this property of metals to change into wires is called ductility. Now, properties of metallic bonding. Particles are atoms, for example sodium, copper, iron, these all examples of metals have positive ions in a sea of electron. As earlier I said, due to the sea of electrons, metals are good conductors of electricity, form giant stable lattices, for example copper, metal. So, are solid except mercury, have high melting and boiling points, conduct electricity when solid or liquid, good conductors of electricity. So, this was all about the metals. Thank you so much.